Since the first exoplanet was found in 1995, researchers have used a variety of techniques to locate countless more. The radial velocity method, the transit method, the direct imaging approach, and the microlensing method are a few of these techniques. The radial velocity approach involves determining how much an orbiting planet's gravitational attraction causes a star to sway. Massive planets near their host stars can be found using this technique. On the other hand, the transit approach searches for minute dips in a star's brightness. A planet moving in front of it is the cause. With this technique, smaller planets can be found, and their size, mass, and atmosphere can be determined. Using sophisticated telescopes to take photographs of the planet using the direct imaging technique is difficult since the planet's light is typically obscured by the brightness of its home star. Last but not least, the microlensing technique finds exoplanets that are far from their home star by using the bending of light caused by gravity. These techniques have led to the identification of several odd and dreadful exoplanets that differ greatly from the planets in our solar system. So, let's look at a few of the most peculiar exoplanets ever found. One of the most peculiar exoplanets, HD 189733b, is 63 light-years away from Earth. This planet is a gas giant that orbits its host star so quickly, 2.2 Earth days, that it is a gas giant. The planet's atmosphere is a deep blue tint due to the abundance of silicate and methane, and its surface is a scorching 1,700 degrees Celsius. Due to the turbulence of the environment, winds can reach speeds of up to 8,700 km per hour or 7 times the sound speed. WASP-12b is a weird exoplanet that lies around 600 light-years away from Earth. With a radius that is around 1.8 times that of Jupiter, it is a gas giant. This planet's proximity to its star means that the gravity of the star is tearing it apart. The planet is shedding mass at a pace of around 10 million tons per second and is being stretched into the shape of an egg. One of the hottest planets ever identified, the planet's surface reaches a scorching 2,200 degrees Celsius. It has a highly peculiar atmosphere with a higher carbon-to-oxygen ratio. It is one of the few planets with such an atmosphere that is known to exist. This highly uncommon gas giant exoplanet, WASP-17b, orbits its parent star in the opposite direction from the star's spin. This was most likely caused by an impact on a large object. WASP-17b is a star with a radius around 1.9 times that of Jupiter and is about 1,000 light-years away from Earth. In the constellation of Ophiuchus, 42 light-years away from Earth, is the exoplanet Gliese 1214b. Due to its proximity to Earth, it was found in 2009 and is one of the most studied exoplanets. A super-Earth is a rocky planet that is bigger than Earth but smaller than Neptune, such as Gliese 1214b. It takes just 1.6 Earth days to complete an orbit around its host star at 0.014 astronomical units, (O). The fact that Gliese 1214b is a water world, a planet with a thick, steamy atmosphere and a surface that is probably covered in a massive ocean of hot, dense water, makes it extremely fascinating. Although the planet's surface is thought to be roughly 230 degrees Celsius, 450 degrees Fahrenheit, which is too hot to support life as we know it, scientists are nonetheless interested in the prospect of liquid water being present there. The atmosphere of Gliese 1214b has also undergone substantial research, which has shown that its main constituents are hydrogen and helium, with minor amounts of water vapor and other gases. The planet's atmosphere is so dense that it causes transit spectroscopy, a process where light from the planet's host star is bent as it passes through. The distinctive features of Gliese 1214b make it a worthwhile subject for further investigation and may offer crucial insights into the origin and evolution of exoplanets. In the constellation Aquarius, some 40 light-years away from Earth, is the exoplanet TRAPPIST-1e. It was found in 2017 as a member of the TRAPPIST-1 planetary system, which is made up of 7 planets the size of Earth that revolve around a tiny, cold star called TRAPPIST-1. The size and mass of the rocky planet TRAPPIST-1e are comparable to Earth's, and it is in the habitable zone of its host star, where temperatures are just adequate for liquid water to exist on the star's surface. Its precise parameters are still unknown, and little is known about its atmosphere. TRAPPIST-1e is one of the most potentially hospitable exoplanets identified so far, which makes it very fascinating. It receives roughly the same stellar energy from the Sun that Earth does, and assuming an atmosphere like Earth's, its surface temperature is projected to be around -60 degrees Celsius, -76 degrees Fahrenheit. Its atmosphere's composition and the existence of liquid water are still unknown. Exoplanet Kepler 62f is about 1,200 light-years from Earth in the Lyra constellation. With a radius of 1.41 times that of Earth, Kepler 62f is a super-Earth, meaning it is bigger than Earth but smaller than a gas giant planet. It is in the habitable zone of its host star, where temperatures are just right for liquid water to exist on its surface. It orbits its host star at a distance that puts it in this zone. The fact that Kepler-62f is one of the most possibly habitable exoplanets identified so far makes it extremely intriguing. Its surface temperature is anticipated to be rough -54 degrees Celsius, -65 degrees Fahrenheit, assuming an atmosphere equivalent to Earth's. It receives around 41% of the stellar energy from the Sun that Earth does. Nonetheless, its atmosphere's composition and the presence of liquid water remain unknown. Being one of a 5-planet system, Kepler-62f is less vulnerable to the impacts of star flares and radiation due to its orbit being close to the border of the habitable zone. These elements make Kepler-62f a suitable candidate for investigations into the search for extraterrestrial life. Almost 200 light-years away from Earth, in the constellation Cygnus, is the exoplanet Kepler-16b. The fact that Kepler-16b is the first exoplanet identified that orbits two stars, or a circumbinary planet, makes it extremely intriguing. It travels 65 million miles around its host stars, which is about how far Venus travels around the Sun. A gas giant planet called Kepler-16b has a mass around 1/3 that of Jupiter and a size roughly equivalent to Jupiter's radius. Its temperature is thought to be rough -100 degrees Celsius, -148 degrees Fahrenheit, which is too low for life as we know it to exist there. Kepler-16b's discovery has provided fresh insight into the dynamics and planetary system development around binary stars. Also, it has shed light on the variety of planetary systems outside of our solar system. We now know more about these unusual planetary systems because of the finding of numerous additional circumbinary planets after Kepler-16b. In the constellation Ursa Major, HD 80606b is an exoplanet that is 190 light-years away from our world. It is categorized as a hot Jupiter, which is a gas giant planet that circles extremely closely to its host and was found in 2001. As a result of its very elliptical orbit, HD 80606b endures severe temperature swings, with its surface temperature rising from about -200 degrees Celsius, -328 degrees Fahrenheit, to over 1,200 degrees Celsius, 2,200 degrees Fahrenheit, throughout its orbit. Extreme temperature swings on HD 80606b have resulted in the development of strong winds with top speeds of 5,000 miles per hour. The big red spot on Jupiter is an example of how strong these winds may make extremely large storms on the planet's surface. Also, it has been discovered that HD 80606b has a peculiar spin-orbit alignment, which indicates that its rotational axis is inclined unusually far with its orbit around the star. This is believed to be caused by gravitational interactions with another planet in the system. HD 80606b's orbit is highly elliptical. Kepler-438b. This exoplanet is around 470 light-years away from Earth and is in its host star's habitable zone. It is thought to be composed of rocks, has a radius that is roughly 0.6 times that of Earth, and gets about 40% more radiation than Earth. In just 35 days on Earth, it completes one orbit around its host star. This exoplanet is comparable in size to Earth, but it is much older. It is thought to be 11.5 billion years old as opposed to Earth's 4.5 billion. This exoplanet's surface temperature is estimated to be roughly -170 degrees Celsius, -274 degrees Fahrenheit, even though it is situated in the habitable zone of its host star. Because of its tenuous atmosphere, it is sufficiently far away to host liquid water and perhaps even life. Yet, the carbon dioxide content of the planet's atmosphere makes it improbable that it could support life as we know it. Because of its high radiation levels, it is also unlikely to be livable. Exoplanet K2-18b is situated in the constellation Leo, 124 light-years from Earth. NASA's Kepler spacecraft made the initial discovery in 2015, and the Hubble Space Telescope verified it in 2019. The super-Earth planet K2-18b has a mass of around 8 times the mass of Earth and a radius of 2.7 times Earth's. The habitable zone, where temperatures are just right for liquid water to exist on the planet's surface, is where it orbits its host star. This has made K2-18b one of the few known exoplanets that may be able to support life as we know it, a particularly attractive target for exoplanet researchers. The atmosphere of K2-18b has been found to contain water vapor, which makes it extremely fascinating. The Hubble Space Telescope, which watched the planet as it passed in front of its home star, made the initial discovery of this in 2019. The observations showed that the planet has high amounts of water vapor in its atmosphere, with values ranging from 0.1% to 50% of the mass of the atmosphere. It might be a water world with a dense atmosphere of helium and hydrogen. Although it is yet unknown if K2-18b possesses the right conditions for life, the finding of water vapor has increased the likelihood that the planet could harbor life. Future studies with more sophisticated observatories, like the James Webb Space Telescope, may provide more details about the atmosphere, composition, and potential habitability of the planet. Overall, K2-18b is an intriguing target for exoplanet research since it is a world that may be habitable and could teach us more about the circumstances needed for life to exist outside of our solar system. GJ1214b is a super-Earth exoplanet with a radius of 2.7 times that of Earth, and it is situated about 40 light-years away from our planet. It has a thick atmosphere that is primarily composed of helium and hydrogen. Scientists believe that because of the planet's dense atmosphere, a deep ocean may exist there. It has a density that is significantly lower than anticipated, indicating that it might contain a sizable amount of water. WASP-33b is an exoplanet that is roughly 380 light-years away from Earth, has a radius that is almost 1.5 times that of Jupiter, and is a gas giant. At a temperature of over 3,000 degrees Celsius, 5,400 degrees Fahrenheit, it possesses one of the hottest atmospheres ever recorded. Its orbit is incredibly inclined, which heats its poles more than its equator. Titanium oxide, which is a major component of its atmosphere and gives it a blue hue, is present there. The exoplanet Kepler 452b is situated in the constellation Cygnus, 1,400 light-years from Earth. With a radius roughly 1.6 times that of Earth, Kepler 452b is a super-Earth planet that orbits its star at about 1 astronomical unit, O, which is comparable to Earth's distance from the Sun. Its orbital period is a little bit longer, at 385 days than the orbital period of Earth. Kepler 452b's resemblance to Earth in terms of size and orbital distance is among its most intriguing features. Given that it is one of the Earth-like exoplanets found so far, it is frequently referred to as a cousin of Earth. Its host star shares many characteristics with the Sun, including age, mass, and temperature. The habitable zone of its host star, where temperatures are just adequate for liquid water to exist on the planet's surface, is where Kepler 452b is situated. This has prompted some astronomers to hypothesize that the planet might someday be habitable, albeit it is currently unclear and challenging to ascertain whether it is. Although having features in common with Earth, Kepler 452b also features some noticeable variations. It is around 60% more massive than Earth, for instance, which raises the possibility that it has a thicker atmosphere and stronger surface gravity. In addition, its host star is a little bit older than the Sun, which may have an impact on the planet's potential for long-term habitability. Trace-2b. Trace-2b is a hot Jupiter planet, which means that while it has a size and mass comparable to Jupiter, it orbits its host star at a much closer distance than Mercury does the Sun. It has a short orbital period of 2.47 days. One of the darkest exoplanets yet discovered, it only reflects 1% of the light that strikes it. It is now darker than coal or acrylic black paint. Its gloomy exterior has earned it the moniker, blackest planet, among some astronomers. Although the cause of Trace-2b's severe darkness is not fully understood, believed to be caused by the atmosphere of the planet. Because of the planet's closeness to its host star, its atmosphere is most likely extremely hot, with temperatures up to 1,800 degrees Fahrenheit, 980 degrees Celsius. This could result in the planet's atmosphere absorbing a large portion of the light that strikes it, giving the impression that it is very dark. Kepler 10c. This exoplanet's initial classification as a gas giant was overruled by subsequent studies, which showed that it is a rocky planet with a mass roughly 17 times that of Earth. It is the heaviest known rocky planet as a result. Some of our presumptions regarding the origin and evolution of rocky planets have been called into question by the finding of Kepler 10c. Current ideas suggest that planets larger than 1.5 times the size of Earth should be primarily made of gas and lack a rocky surface. Despite its enormous size, Kepler 10c appears to have a rocky surface, which raises the possibility that there are other processes involved in the creation and evolution of planets. One of the hottest exoplanets ever identified is Kelt 9b, which is around 650 light-years away from Earth. It is hotter than certain stars, with a surface temperature of over 4,000 degrees Celsius, 7,200 degrees Fahrenheit.